Hey there, space enthusiasts. Welcome back to SingularityVault, your gateway to the wonders of science and engineering. If you're as fascinated by the cosmos as we are, don't forget to hit that subscribe button and ring the bell to join our spacefaring community. By subscribing, you're helping fuel the algorithm and ensuring that more curious minds like yours can explore the mysteries of space with us. Your support means the world, or should I say, the universe to us. Now let's dive into today's mission, tackling the space junk crisis. Ready for liftoff? Imagine staring into the vastness of space, only to realize that a hidden danger lurks closer than you think. Picture this. You're not alone up there in the infinite cosmos. Orbiting right alongside our planet are millions of fragments of space debris. These are not shooting stars granting wishes, but remnants of defunct satellites, spent rocket stages, and fragments from disintegration and collision events. They whirl around Earth at breakneck speeds, posing a serious threat to our astronauts and spacecraft. This isn't just a scene from a sci-fi movie, it's a real-life issue that scientists have dubbed the Kessler Syndrome. Named after the NASA scientist who first proposed it, the Kessler Syndrome predicts a scenario where the density of space debris in low Earth orbit becomes so high that collisions between objects could cause a cascade, each creating further debris, making space travel an impossibility. As we float amidst the stars, an invisible threat surrounds our home planet. Our Earth is encircled by various orbits, each with its own cloud of debris. Let's dive into the details of these orbits and their unwelcome inhabitants. First off, we have the low Earth orbit, or LEO for short. This orbit, spanning from just 100 miles above our heads to about 1,200 miles, is the most densely populated. It's like a bustling city, but instead of people and cars, it's filled with satellites, spent rocket stages, and a whole lot of debris. This is where the majority of space junk is found, making it a veritable junkyard in space. Next up, we have the medium Earth orbit, or MEO. This is a more spacious neighborhood, lying between 1,200 and 22,000 miles above the Earth. It's home to navigation satellites like the ones that power your GPS. But don't be fooled by its seemingly serene nature. This orbit too is littered with remnants of past missions. Finally, we have the geostationary orbit, or GEO. Situated a whopping 22,000 miles above the Earth's surface, this orbit is a prime spot for communication and weather satellites. But even this high-altitude neighborhood isn't immune to the clutter. Broken satellites and spent rocket bodies are strewn about, adding to the ever-growing cloud of debris. The truth is, every orbit around our planet is littered with the remnants of our space exploits. From tiny flecks of paint to defunct satellites, this flotsam and jetsam of space travel poses a serious threat. Each piece, no matter how small, travels at speeds high enough to cause significant damage to anything in its path. The severity of the problem is staggering. It's estimated that there are currently over 100 million pieces of debris smaller than 1 centimeter, and about 500,000 pieces between 1 and 10 centimeters. And these numbers are only set to increase unless we take action. As we venture further into the cosmos, the clutter we leave behind only grows. And with each new launch, each new satellite, we add to the problem. As we continue our journey into space, we must also tackle the challenge of cleaning up after ourselves. Because after all, we don't want our legacy in space to be a trail of debris. Ever heard of the Kessler Syndrome? It's not a sci-fi movie plot, but a potential reality. Imagine a domino effect, but instead of dominoes, you have satellites. And instead of a tabletop, you have the vast expanse of Earth's orbit. That's the Kessler Syndrome in a nutshell. It's a theoretical scenario proposed by NASA scientist Donald Kessler in 1978. He warned that as the number of artificial satellites in Earth's orbit increases, so does the probability of collisions. And these aren't your everyday fender benders. We're talking about high-speed impacts at several kilometers per second, enough to shatter satellites and generate a cloud of debris. This debris, in turn, could hit other satellites, creating even more fragments and setting off a chain reaction of collisions. Now you might be thinking, but space is big, right? Surely there's room for a few more satellites. Well, that's where the crux of the problem lies. Space might be infinite, but the orbits around Earth where we can effectively place satellites are not. These orbits are becoming increasingly crowded, and with every new satellite launch, the risk of collision escalates. What's worse is that this isn't a hypothetical scenario anymore. We're already seeing signs of it. In 2007, China's anti-satellite test, which intentionally destroyed a weather satellite, added more than 3,000 trackable debris fragments to the Earth's orbit. In 2009, the Iridium-33 and Cosmos 2251 satellites collided over Siberia, generating a debris cloud of their own. These incidents are just the tip of the iceberg. There are millions of smaller debris pieces that we can't track, but they're still capable of damaging or even destroying satellites. If the Kessler Syndrome were to fully kick in, it could create an impassable barrier of debris around our planet, potentially halting all space exploration and satellite services. The Kessler Syndrome isn't just a theory, it's a ticking time bomb. So, are we doomed to be forever trapped on Earth? Not if we act now. You see, humanity isn't known for sitting idly by when faced with a challenge. We're already developing missions to tackle this space debris menace. A shining example is the ESA's Clear Space 1 mission, set to launch in late 2026, atop a Vega C rocket. This mission aims to capture and deorbit a part of an old Vega rocket, a small step towards a cleaner orbit. But this isn't just about cleaning up after ourselves, it's about preserving our ability to explore the universe. Each piece of debris we remove is one less obstacle for future missions, one less threat to the satellites that connect our world. And as we look to the future, we see a horizon filled with possibilities. From debris tracking satellites to innovative cleanup technologies, we're devising new ways to keep our orbits clear. We're building a future where space debris is not an insurmountable wall, but a hurdle we've learned to clear. Of course, these missions are just the beginning. We need more hands on deck, more minds tackling this problem from every angle. Because when it comes to safeguarding our cosmic frontiers, every effort counts. So as we stand at this juncture, staring at the stars and the challenges they hold, we are reminded of our capacity for innovation and resilience. Yes, space is cluttered, but it's not lost. With the right steps, we can clean up our cosmic backyard. Our journey into the cosmos depends on the actions we take today. Let's make it a mission to keep the skies clear for future explorers. Share your thoughts, ideas, and concerns about the urgent matter of space debris. Are there other innovative solutions we're overlooking? Let's get this conversation orbiting around the globe. And remember, if you're captivated by the mysteries and the future of space exploration, subscribe to SingularityVault. Together we can ensure a future where the stars remain within our reach.